Okay, so section 5.3, yes.
Remember what I'm going to do now? Isn't it supposed to be equal to something? You said verify the identity.
Yeah.
Yeah.
I got confused.
Do they have an equal sign?
No.
Okay, don't worry about it. Take it off.
Thank you.
Okay, so tell me that while you have it there at your... Okay.
I just.
Okay. So 5.3. 5.3.
I just put in.
5.3, there is 3 different items in 5.3. Out of the 3 different things we could learn, I'm only going to teach one of them. So that's why I only wrote down double angle formulas. If you looked up chapter 3, it's going to say way more than that. So this is the only piece I'm going to hold you responsible for. And the reason is I'm starting to narrow in on what you need for BC calculus. Okay? Pretty much this whole entire course is about getting you ready for BC calculus. So now I'm going to be kind of picking and choosing what you need. And so you are now responsible to derive the formulas. For example, on that do now, I had you write out those 6 formulas, right? Just write them out from memorization. Well, on these 1, 2, 3, 4, 5, you will have to not just give it to me, you will have to show me how to get this. You will have to derive it. And I'll show you those derivations next. That's what I'm going to do. But you're going to be responsible not only for memorization, but to tell me where that came from. Where that came from. So I will scoot this up. And there's just 3 different cosine to this. So double angle. There's the angle. It's double. That just means 2 times, right? That's a double angle. Whatever that angle is, it's been doubled. So these are the double angle formulas. It doesn't just say theta. It now says 2 theta. So sine of 2 theta equals 2 sine of that single theta times cosine theta. Over here, we understand that. The theta could be a 30 degrees, a 45 degrees, a pi over 2. We're good with that. But we do not know how to do 2 times that. And so now these formulas will allow you to go from something I don't know how to do to something I do know how to do. Same thing as what we did yesterday. We did not know how to do cosine of 75 degrees, but we used the sum and difference formulas in order to, so that we could solve it. Same thing with these. So let's do the first derivation that you're going to be responsible for. Sine of 2 theta. So this is a derivation. It's a little bit different than a verify identity. I'm going to start with stuff that I know in the past. This is just like geometry. I know that's like a dreaded word, the word geometry, but in geometry, you couldn't use something until you proved a theorem. Once you proved it, then you are allowed to use it. Okay? Same thing here. Sine of 2 theta, how do I really know it's this? Well, let's use what we know from the past. Well, do we know? Well, last section, I know the sum and difference. So couldn't I actually rewrite this as sine of theta plus theta? Isn't theta plus theta 2 theta? Now that looks like the sum formula for sine. And so let's use that. You want to write this down because you're responsible for this. Let's see, what was that formula? That was sine of alpha times cosine of beta plus sine of beta times cosine of alpha, except my alpha and beta are identical this time, right? And then, oh, isn't there just 2 of these? Oh, that's where that came from. I derived it. I proved it to be true from things I know in the past. Yeah, it was just yesterday's section, but it's still the past. This is what you'll be required. I will have this on probably on a do now before we get to a test, but it'll also be on the test. I will give you this. You will have to show me the derivation. You may not just do this like I allowed you to today. I didn't make you responsible for those wonderful, wonderful proofs that Mr. Otteson did on Friday. Cosine 2 theta, I have 3 of them I have to derive. Well, why don't we start with what we just did? cosine of theta plus theta is the same thing of cosine 2 theta. And we'll use the formulas from yesterday. Let's see what that was. Cosine of alpha times cosine of beta minus sine of alpha sine of beta. Oh, that's really cosine squared minus sine squared of theta. Okay, so there that is, and there it is, right? I did the first one, right? So from this one, I can rederive this. How could I get this to this? Well, let's think about verify identities. I want cosine to stay. I want u to go away. How can I get rid of a sine squared theta? What could I replace it with? 1 minus cosine squared theta. That's the path I'm going to take. For me to go from here to here, well, I want to keep sine. I want to get rid of cosine squared theta. I would replace it with 1 minus sine squared theta, right? That's my plan of attack in my derivation. So let me derive that. So again, I have to derive the next one. I would redo what I already did to get to this. I'm not going to redo it, but you will be required to redo it. Then, and each one of those next two, I'm just going to get rid of one at a time, right? So let's see, how about I get rid of this one first? That is really the same thing as 1 minus sine squared of theta minus sine squared of theta, right? So that's equal to 1 minus 2 of those sine squared of theta. Is that like one of the ones on the first page?
Yes.
There it is. Again, what you're going to be required to do is start from the absolute beginning every time. So I'm just going to practice it one more time, and then I'm going to get the other one. Cosine of alpha times cosine of beta minus sine of alpha times sine of beta. It's cosine squared of theta minus sine squared of theta. Let's see. I got rid of cosine. This time I'm going to get rid of sine. I better distribute my negative. So now there's 2 of these cosine squared thetas minus 1. And that should be, and it is, the other one. You will be responsible so far for all 4 of those derivations. I will stop for a moment as you catch up to me. Last one, tangent of theta plus theta is the same thing of tangent 2 theta. So let's see, how did that one go? I'm trying to remember in my head how that one went. Tangent of alpha plus tangent of beta. Let's see, what was that? Tangent of alpha plus tangent of beta, and that was 1 minus tangent of alpha times tangent of beta, right? And that was from tangent alpha plus beta, which is what I'm mocking, okay? So that would be that would be this, 1 tangent theta, tangent theta. Oops, sorry. So this is what I'm using from yesterday to model. I got to clean that up. There's really 2 of those because the angle is the same. This is the same, so it's actually squared. Oh, that totally is that formula. I just proved it to be true. I derived it. Do you understand what I just did, how I used yesterday's, all their formulas? Use the sine, the cosine, and the tangent. And I used only the addition, not the subtraction. So now I just did what Addison did for you on Friday. That's what I just did for this section. I derived them. Now I have them. Now I'm going to keep these things handy. Now let's go do math. All right. Here's a problem. Go ahead and write that down. This is my given information, and this is what I'm asked to go find. There's 3 things I have to go find. So it says sine of theta equals 4 over 5, comma. It also tells me that this theta is in quadrant 2. Then I'm supposed to go find all 3 of these double angles, sine of 2 theta, cosine 2 theta, tangent of 2 theta. Okay, so this is not this. If this is 30, this is 60. If this is 15, this is 30. These are not the same thing. So maybe what I better go do is just see what I can do with this. I'm going to go make a quadrant 2 reference angle. That angle is going to be called theta. Make sure I name that properly. It tells me that sine is 4, that's opposite over hypotenuse. We know that is a triple, and we know that's a 3, but because I'm in quadrant 2, I'm going to put a -3. We okay with that? Okay. That still doesn't help me answer sine of 2 theta. I don't know how to answer it the way it is. But what I can do is I can use that formula. I know how to rewrite it in just thetas. That's 2 times sine theta cosine theta. Isn't that what it tells you in the formula that we derived? That I can go find. 2 times this, because here's my theta right there in that triangle. Well, sine of theta, well, they already gave it to me. It's 4 over 5, and cosine of theta is -3 over 5. Let's see, that's 25 in the denominator. That's 12 and 2 12, so it's -24 over 25. So I couldn't answer this, but this side I can. This I could not, but on the other side I could with the addition or subtraction. I'm going to do over here cosine of 2 theta, because I've done that one. Well, let's see. I can choose any one of the 3 I want. I think since they gave me sine, I'm going to go ahead. It doesn't matter which one you choose. I think I'll just choose that. I mean, just it doesn't matter. You'll all get the same answer. So 1 minus 2 sine squared of theta is the same as this. Equals 1 minus 2, whatever sine theta is squared. Remember that? Right? And so sine of theta, there's that theta. Sine is 4/5 equals 1 minus 2, square that. That's 16/25. And then 2, that is what, 32/25? And then I need to make that into 25 minus 32 common denominator. Hopefully you know exactly what I did there. And you can ask me anything you need to. I think you're probably okay with my algebra. Tangent of 2 theta is what I have left. I only have one formula because I can't answer that because my triangle is only in theta. So I have to rewrite it where I can get theta. So that formula is what? 2 times tangent of theta all over 1 minus tangent squared theta. 2, got to get that answer. 1 minus, get that answer and square it. I like making templates. I minimize my mistakes. All I have to do is get tangent of theta and throw it in there. And that would be what? Right, so I could just put -4 over 3. Doesn't matter where the negative goes, just so you know that that fraction is negative. So now I have to be very careful here. That's a negative 8 over 3 in the numerator. Denominator, 1 minus, that's going to be positive, so that's going to be what? 16/9. In the denominator, I'm going to get a common denominator, which will be 9. That's 9 minus 16 over 9. Okay, I'm going to stop for a minute. You see what I'm doing? I eventually want one fraction over another so I can multiply by the reciprocal. That's called a complex fraction, and we don't like ever box it in an answer that looks like this. I'm going to have to go this way. 9 minus 16, that would be a negative 7/9. Now I'm going to multiply by the reciprocal. Is that okay? Yes? There's the homework. I'll be done. I'll put the book underneath, and you'll have 15 minutes to work on it already. I didn't know I'd be done so fast.